Good afternoon, class. Today we're going to be learning 5.4, solving special systems of linear equations.
Perfect. Thanks, Will. Yeah. All right. So we did a little warm-up there, right? We talked about 3 different methods we could use. Substitution, elimination, and graphing. So we'll talk a little bit about graphing first, all right? So the different possibilities that can occur when solving a system of equations graphically, all right? So you guys have all the graphs on there, right? Lines there, I'm not sure.
Let's not show all that yet.
You want to show this, Mr. Hager?
Didn't want to.
That's okay. Sorry, Mr. Hager.
Yes.
All right. Kind of scroll down like this.
Sure.
That's all I want to do. All right. So guys, on that line you have there, right? You want to write in a system of linear equations can have one solution, no solution, or infinitely many. Right.
I did this last year.
You may have.
The math club teacher told us we already did this, so she gave us a complete lesson on it, and I didn't have no idea how to do it.
Okay.
She said she discussed it with you guys, so I guess she knew how to do it.
Oh my gosh.
She just assumed how to do it.
Just say hi.
Right?
All right. So system of linear equations can have one solution, no solution, infinitely many. All right. So you guys have the pictures on your guided notes. So that first one, right? That first picture, it has one spot where the lines intersect. So if I have a graph that looks like that, do you think that's going to represent a linear equation that has one solution, no solutions, or infinitely many? Say it. Not infinitely many. That first graph on there, the first one, furthest to the left.
No, it's kind of one.
It's going to have one, right? It can only be that one point. All right. So for that first picture, all right, for that first picture, you're only going to have one solution. So on the top, you have a line, right? On that line, you want to write one solution. Then below the line, you want to write the lines intersect.
Let's remember, solutions are points that are on both lines at the same time. Imagine where those lines cross. If you put a dot there, it would be on both lines at the same time.
Yeah. So if they intersect at one point, what that means is, guys, the equation that they give you, the slope will be different and the y-intercept will be different. All right? Again, what letter is going to be with the slope? Right? X, right? So it might give you something like this: y equals 2x plus 5, y equals negative 3x plus 1. Number with x is like you guys just told me, is the slope. They're different. The y-intercepts are different. So different y-intercept, different slope, you can have one solution only. All right? And again, if you don't know, guys, based on this looking at the equations, to know how many solutions they're going to have, that's okay. All right? I'm just giving you a little hint here that if the number with x is different and the number itself is different, the number at the end, that means you're only going to have one solution. All right? That next one you guys have are 2 lines that don't intersect at all.
It's no solution.
Like Joe just said, that's going to be no solution. Reason being, Joe, how come?
Because both ways are going.
Yeah, the lines don't intersect at all.
Nice.
Right? The lines are parallel. That means they're going to go on forever, but they're never going to intersect. They never ever will intersect.
That's a parallel.
So, when I have that, what that means is the number with x, or the slope, will be exactly the same in both equations. All right? So we could have y equals 2x plus 3, y equals 2x minus 7. Because the number with x is the same in both equations, that means that the lines will be parallel and they won't intersect. That means there's no solution at all. So we did one solution. We did no solution. That means the last one's going to be what? Infinitely many. That means
Yeah.
it's like you can have as many solutions as you want. That means it's going to be the exact same line. That means the slope is the same, the y-intercept is the same. All right? You can just take it and it'll go right on. So that means every point on that line is a solution. So you can't really put a number of the solutions you're going to have because there's so many. So you might have y equals negative 3x plus 4. Y equals negative 3x plus 4. Exact same slope, exact same y-intercept. That means there'll be infinitely many. That makes sense? So again, this is if I'm dealing with graphing. And we're going to talk about in a second, guys, which method you want to use to solve. Sometimes the direction might just say solve by substitution. But it might say, directions might say solve the system of equations. You don't know what method to use if we don't tell you to. So sometimes, obviously you're going to know if it has a graph on there, you're going to solve it by graphing. All right? So let's look at, on your notes next, what method to use. We kind of talked about this a little bit in the warm-up. All right? So we talked about, like Savannah told me, x plus or minus y equals a number. If we have that set up, like I think it was the second example we did, or the second example we looked at after we did the basic arithmetic. If we had something like this, that means I want to use elimination. X plus or minus y equals a number, use elimination. I mean, you could use another method. You could use graphing. You could use substitution, but you have to move a bunch of stuff around to get to that point. If it's already set up like this, x plus or minus y equals a number, you're all set. You're going to solve. You don't have to worry about it. All right? Now, y equals, you could say number with x, but mx plus b. So what that means is y equals number with x plus just a number. All right? So you can use two things for that, two methods. You could use graphing, but here's a little hint. If we want you to solve it by graphing, we're going to give you a graph. Directions may not say it, but if you see a graph with that type of problem, right, you want to solve it by graphing. Or you could use substitution. And again, the directions may tell you, but sometimes the directions don't always, sometimes we don't always give you the directions. Sometimes you have to decide for yourself what method you're going to have to use. All right? So elimination, right? Elimination, graphing, substitution. You decide. And I think for the first example we do, guys, we're going to show you both. I think we'll show you one method algebraically. That means we'll actually do it out using either elimination or substitution. And then we'll do it also with graphing. So you can see you get the answer both ways. All right? Let's say you want to.
All right, so let's look at the directions. It says solve algebraically. It says solve graphically. They gave us a grid, so we know we'll do the graphic one after. Which way is usually more accurate? When we do it with algebra, or when we draw a picture and try to see where they cross? Yeah.
Algebra?
Yeah, algebra you get an exact answer. Graphing, you need a ruler. We need, make sure they cross at a nice spot. All right. So out of the three methods Mr. Roy just mentioned, substitution, graphing, elimination, which one, again, there might be more than one, but which one could we try here? Okay, we could do elimination. Yeah, because we have same number, same letter, opposite sign. If you didn't want to use elimination, what could you use?
Substitution.
You could do substitution. You could take this and plug it in right there. But Joe said elimination, so I'm not going to do it that way. All right. So if we look at it, same letter, x and x. Same number, 3 and 3, -3 and -3. So let me ask, do people want to do elimination or substitution? Which way?
The one where you plug it in.
That's substitution.
Can we do
Yeah,
that?
let's do substitution.
Okay, so that one's a little harder. Okay, so if you want to do it the way Joe mentioned, that'll work. But some people have trouble with substitution, so let's practice it. Step 1, put parentheses around what y equals. Put parentheses around y in the top one. Okay. Now, what do I do? Yep,
We plug in for y.
plug in for y. So now my top equation, is the 3x plus 12 going to change? No, we keep that exactly the same. On the left, you're not going to put y anymore.
You're going to put the -3x to 6.
You're going to put negative 3x plus 6. All right, so first step, let's get all the x's on one side.
So -3x.
Okay, we could minus 3x from both sides, that's fine. That's gone. What's negative 3x minus 3x? Negative 6x plus 6. And what's still on the right side?
12.
12. All right, I got 2 steps left.
-6 from both sides.
Good.
They're both, then you divide -6 to both sides.
12 minus 6?
Oh,
Six.
6.
6.
Then you subtract -6 from both sides.
So we're all done with subtraction.
We want to
Divide.
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 Yeah.
Oh,
My Joe, gotcha.
And what are we dividing by?
-6.
Negative 6.
-1.
So we get x equals -1. Okay, so are we good?
No, we have to find y.
Right, we did the hard part. We've got x. We have to find y.
And substitute x into any equation.
Exactly, everyone here, either equation. I might do the top one because it's all positive numbers. So let's plug that in. Right there. So we get y equals,
No.
what's 3 times -1?
-3.
So -1, 3 times -1 is -3. -3 plus 12,
9.
9. And there's our 2 answers. -1, 9. So now that we have those, when we graph it, we already know where these lines should cross. -1, comma 9. So that's kind of an advantage of doing the algebra first, is we already know what the answer should be as a graph. Okay?
No, time to go.
Questions on the algebra? Okay. Graphing. I'm going to copy it down again so I can see it. Same equations, I just don't have enough room to keep looking at them and
Wait,
scrolling
why
up
don't
and
we
down.
just put the answer down?
Yeah.
We did. -1 and 9.
Why don't we graph it with
Yeah,
that?
yeah, why don't we
Yeah,
do
let
that?
the teacher do his thing.
Now we're going to graph it.
You know what?
We're going to graph it.
You want to go that says
What?
Okay. Let's start with the top one. Okay. How do I graph that? What's the first thing I have to do?
You have to, so don't you have to solve or?
I'm not good at this part.
Oh, wait,
I'm not-
so we have
I'm
to
not
solve.
We're going to put a dot somewhere
Oh,
first.
12 on positive.
We're going to put a dot on positive 12. Now my graph only goes up to 10, so I'm just going to estimate 10,
I forgot.
11,
I don't know what's X and Y.
12. Okay, that's the best I can do. Because I'm estimating 12, my graph might not be perfect.
Go by twos. Oh.
Yeah, you could go by 2s instead, but that's okay.
So, in reality, it's better to do it algebraically.
Do you want to go by 2s?
sure.
No,
Okay.
no, I don't.
You can keep yours the way it is if you want, but some people say, why don't we go by 2s?
We're just gonna.
My graph goes up to 10.
Yeah.
Yours goes up to 10?
No, but it
Yep.
says 12.
Oh, that's 12. Okay.
So 12.
Yeah, just like-
Hey, Peter.
So Joe gave us the suggestion, why don't we just go by 2s? That's fine. So up 12, put a dot. And now what about the 3?
That's why you
Yeah.
Right, up 3 and over 1. Is that the same as up 6 and over 2? Yeah.
Yeah, because if you reduce it, it'd be.
It's the same thing. The reason I'm doing that is because if I want to go up 3, it's kind of weird. I'd be like in the middle. I mean, I can do it. What's up 3 from 12?
15.
15, so I'm in the middle. And then I'm going over
18.
over how many?
15 plus
Oh,
3 is 18.
Where'd
Where'd you get 3 over 1?
That's the slope.
12.
3 over
Where'd you get
1.
the 1 from?
What's number
Make a
sign is
fraction
that
so you
up
can
top?
Yeah, you just make it a fraction. Just make it a fraction.
What sign is that up top?
Okay? So now I'm going to do it again. Up 3 from 15 is how much? Up 3 from 15 is 18. And then over
Maybe I shouldn't have done that.
14,
Over 1.
15, 17.
Now look at the original. If I had just gone up 6, 2, 4, 6 over 1, 2. It would have ended up right there anyway.
Now when you go down 3, over 1.
No, you don't need to. That's enough. Just make our line.
Sick of you. Told me that was this.
Will? No more comments like that. Thanks. Okay.
What's the number sign at the top next to 3 over 1?
Equals 3 over 1.
So what was the answer?
In the top right corner.
Top right corner, that just says 3 over 1 equals 6 over 2.
Oh, I can't tell what that is.
But,
Now, how do we graph the second one? Because the answer is where they cross.
so you go up.
Put a dot at 6.
And
Okay.
then you go down 3 over 1.
Down 3. So down 3
Over 1.
over 1. Down, what's down? I'm at 3. If I go down 3 again, where am I?
Wait, we're at 3?
I'm at
So
3
you're
right
at
now.
0
0.
over 1. But now you have to go up.
0 over 1, what?
Okay.
What's
What does that mean?
So we're just graphing y equals mx plus b.
Now we draw one.
Is there going to be any graphing on the test this week?
Oh,
I
yeah.
really don't like the graphing.
Yeah.
That's
But the graphing isn't new. We've done it before. We're just trying to remind you about it.
I know, it was just so confusing. Like, I failed the graphing on the test, and I was like, oh, we're not going to do it again. It's no big deal. Just one test failed.
Graph's
Now-
gonna follow you for the rest of your life.
Here's the answer. Right there. The problem is, it's kind of hard for me to tell because they don't line up exactly. Where should the answer be?
It should
Exactly.
be on 9 on something.
Should be negative 1,
I said
9. Are we close? Right here?
Close enough.
Pretty close. It's not bad, right? Left 1, up 9. Okay, but that's the problem with graphing. If you really look at it exact, it's not perfect.
So why do we do it if it's not exact when we know there's a way to be better by just doing that?
Because sometimes we don't like to do algebra and we rather just draw a picture instead of having to do out algebra.
Can you give us a choice?
Some problems you will have a choice. Yep.
Yay!
Because I don't like graphing. It's really confusing.
This might be one of the only ones you do both. Okay. Does anyone have any questions on
Yeah.
how we did it with substitution?
No, substitution's easier.
And then remember, with graphing,
Oh.
step 1 is to graph your y-intercept. Step
Can
2,
I write this down?
yep. Step 2, after you graph the y-intercept, use your slope. Okay, slope is rise over run. So if you had something like this, step 1 would be to put a dot on 5 on the y-axis. So if you had graph paper, put a dot on the 5.
What would that be instead of 5? Like put it on there,
Put a dot on the y-intercept. And now use the slope. If the slope isn't a fraction, what number can you always put?
1.
Over 1. Slope is rise over run. So now, from where your y-intercept, step 2 is to go up 4 and right 1. If you wanted to write that in general, you would just say from your y-intercept, use your slope to graph another point.
So step 2 is to use your slope.
Yep, use your slope to graph another point starting from the y-intercept. Remember, rise is up if it's positive, down if it's negative. Run is always to the right. Rise is up if it's positive, down if it's negative. Run is always to the right. Right.
There's no other steps?
That's how you graph. Nope. And then after you do those 2 steps, you'll have 2 dots. Then just draw a line. You have to draw a line. Okay.
I hope you're shining.
Okay, if we have time at the end, I can try graphing another one, but we're not really going to spend a lot of time on graphing today. We'll practice it more tomorrow, but not a ton today. Okay, let's look at this one. Do you guys already have that written down? No.
Hey, you better stop. You better stop.
So what is that set up for graphing?
No.
No, if it was set up for graphing, it would look like this. It would have y equals, you'd have a number here, a number here. That's not what that looks like. Is that set up for substitution?
No.
Set up for elimination.
It's set up for elimination.
Yes.
Substitution would have a letter by itself.
Yeah. but-
Elimination has x plus or minus y and then a number.
So it's elimination.
Yep, so this is elimination. So that's the first thing I'm going to write down. We're going to solve with elimination. Any questions on how we figured that out? Because you have a choice here. It just says solve. You're going to have to figure out on the test to use elimination.
Yeah.
Oh,
we
wait,
can't do
I
anything
think I
else.
know how to do
Wait, so
this.
we just have to see. Oh, wait.
No,
Now
we
we'll
have to
solve.
do it too.
Now we're going to do it.
Oh, this is positive.
So let's pick a letter first. Do we want to get rid of the x's or do we want to eliminate the y's? X's. Okay? So we're going to get rid of those. What equation am I going to have to multiply so that eventually I can make one of these numbers the opposite of the other one?
The first one.
Oh, times 4.
The first one.
No, negative 4.
Negative
I
4.
said it first.
So start with that. We're going to multiply the top one by negative 4. Why? What's 8 times negative 4?
32.
Negative 32.
Negative 32. What do you have below it?
Oh, shoot. I missed.
So negative
X.
32.
Oh, 32x.
Something.
Wait.
Positive
wait,
32.
It
Plus
cancels
8y
out.
equals- No, because it's negative. Doesn't it not?
So the bottom equation, I didn't do anything to it. The top one, let's multiply out negative 4. Negative 4 times 8x.
Negative 32.
Negative something.
32x.
X.
Negative 4 times negative 4y.
61.
Good. Negative 4 times 20.
Negative 80.
Negative 80. Now the bottom one, what did we do to that?
Nothing.
Nothing. Copy it down. 32x minus 16y equals 48.
Oh my gosh, it's ready now.
It's ready. What's negative 32x plus 32x?
0.
0. Gone.
Then that one crosses out
Okay,
too.
so this is no answer.
0. Yeah, something's going to happen here. What's positive 16
Zero.
minus 16?
0.
0. So all of a sudden we have 0 plus 0
Sorry.
equals 48.
So it's infinite? What
So-
about the negative 80?
Where did I get what?
The negative 80, how do you just get 48?
Negative 80?
Well, yeah, no.
Negative 4
Why didn't
times
you
20.
subtract?
No, yeah, the negative 80 and then a 48.
Oh yeah, you mean, and thank you. Yes. We do need to add those. So that should be
What
negative
did I
32.
subtract?
It's a key.
Oh, yeah.
Negative 80
It's called.
and 48 is negative 32.
Yes.
Now, when all your letters disappear on one side,
Where'd you get 48?
one of two things happens. It's either no solution or infinite solutions. How do you know when it's one solution? It wouldn't do this. It would do this. This was a one solution problem.
Okay.
The lines crossed in exactly one
So
spot.
are there no solutions?
Well, let's see. Let's finish it up.
I say no.
What's 0 plus 0?
0.
This says 0 is the same as negative 32.
No.
True.
No, there's no solution.
Negative 32 is little.
See, I did this last year.
Can't see.
I hit on B, but never mind.
Okay? So if you get to this step and you end up with no letters and you read it to yourself, 0 is the same as negative 32. No. Okay? That's no solution. Okay? This is not true, which means no solution. If you ended up with something like this, 5 is the same as 5.
And there's a true solution.
That's true. We're going to do one of those next.
What happens if it was negative 5?
That's 5 is not equal to negative 5. So if you get a number on the left and right that are different, like this, no solution. If you get a number on the left and right that are the same, you're going to see what happens right now. Okay?
Is the next, do we have to graph the next?
No, you don't have to graph this one. It didn't say to.
No, the next one.
The next one. Yes.
But I don't,
This one we have to graph. Yeah.
graphing's hard. Can we do it together? Because I can't do it by myself.
Sure.
So we had a no solution. We had a one solution. Do we have an infinite amount of solutions? Okay. I'm not seeing that. That would not be infinite. So
They don't have that, they don't have the one written down anyways.
I'm going to change it so that we do one that's infinite.
Okay.
We're going to solve by graphing. And then you need to see what happens when you solve with algebra.
Okay. Which one are we going to do first?
We're going to do graphing first.
Yay.
Get the hard stuff over with.
So that's part of that.
That's the new one.
That's the second one.
That's the second one. All right. Is the first one ready to graph?
Yes.
Yep. It's in y equals mx plus b. Y is by itself. Good to go. What's my first step to graph it?
I wrote it down. Wait. Graphing. You find the intercept.
You put the dot where the negative 3 would be on the graph.
You
Put
find
it-
the intercept and you put it
Yep.
on the graph.
Find the intercept. What's the intercept? Negative 3.
Wait, did you combine them?
Nope.
No.
No, he changed it so that it would be easier.
Oh, so you
So-
like multiplied by 2.
Well,
Oh, he
that's
changed
what I
it
did,
logically.
but you don't need to worry about that.
And guys, for this one, it says solve by graphing, so we have to solve by graphing. But if it didn't say that, what may have been a better option?
Elimination.
What might have been a better option? So not elimination, not
Substitution.
substitution, right?
Why would
We're
we
gonna
do
do that in a minute.
substitution for that one?
Because everything that goes with graphing is substitution too.
It can be a lot of times, yeah, because the letter's by itself. Yeah.
Okay.
Good. Now, what about the 2? What's the 2? 2 over
That's slope
2 over
1.
1.
2 over 1. So what do I do from here?
You rise
rise.
2 and then you run 1.
Run to the,
Left.
Right.
No, it's
Right.
positive, right?
always go to
You
the
never
right.
go to the left.
Never go to the left, exactly.
Unless for some reason you're going to go off the graph and have to do the opposite.
I don't even know if I'm lined up.
Okay, so just draw it the best you can.
You like this?
This will probably be good enough. We'll see. Okay, is the second one ready to graph?
Oh, no, it's not yet.
No, it's got to be like this.
From everything.
What did you just say, Joe?
Divide 2 from everything.
Divide 2 from everything.
And then be y equals 8x minus 12.
What's 4 divided by 2?
Yeah, why do you have to divide?
It's 4 times 2.
Oh, 4 times. Oh my god. It's
2. And what's negative 6 divided by 2?
positive 3.
Negative 3.
Negative 3.
now we've got y by itself, which is what you have to do when you're graphing. I just answered your question. Because you have to get y by itself when you're graphing. Okay, we've got to get it in y equals mx plus b. Now, look at what we have.
The same thing.
It's the same thing. Y equals 2x minus 3, y equals 2x minus 3.
So there's infinite solutions.
Same equation. So now to draw my line,
Yeah.
it's right on top of it.
Why did you pick 2 though? Or did you just know that you need to pick 2 for that to happen?
Because I have to get this by itself, so I divide by 2 to do that.
So if you left it like that, would you still get an answer, or would it like not come out at all?
Well, we graphed it, we saw it's the same line. So remember what Mr. Roy said about same line? Right
I
here?
mean, like, you normally change the second to something different.
Yeah, because y wasn't by itself just in the second one. It was already good in the first one.
Oh, I was just like.
We get y equals mx plus b.
Hey, guys, Mr. Hager did it that way because he didn't want to give the exact. He didn't want to give the exact same equation in both. He wanted to have you do a little bit of work to get to that. That's all.
Yes, I'm aware. What?
All right, so now Mr. Roy just asked somebody what method should we use with algebra. Is this set up for substitution or elimination?
A substitution.
Substitution. Okay, let's copy down what we had again so I don't have to keep scrolling. So copy this.
So write down y equals. Mr. Hager's gonna write it down.
We're rewriting this.
I have no reason.
Well, I rewrote that.
And the other one was 2y equals 4x minus 6. Okay, what's the first thing I do with substitution? I have to put, yep,
So with substitution, you have to find which one goes into each other. Like
I have to draw some symbols first.
a negative. What?
Symbols? What are you talking about?
Yeah.
Oh no, you have to get them both in the white.
Do we have to?
I have to
like,
put some-
Oh, the parentheses.
Parentheses.
Jesus Christ.
Jesus.
I
bulb.
No, it's not Jesus, Joe, it's math.
So I was trying to think.
Wait, why did you do it for that one when you could have plugged it in for that
Is
one?
this under example 4?
No.
Wait, why did you do that one?
Because you always put parentheses around the side where y is by itself.
No, really.
Oh.
Okay, you always put parentheses around the side where y is by itself. Where else do I put parentheses?
Around the Y.
All right. Now what?
Plug in
Plug it
2x
in.
minus
Something.
3 into y.
Exactly.
Now, how come this is going with the same problem?
Because you need to see an example with algebra, and I didn't see one in the notes that was an infinite
So
solution.
this is okay. So this is just another example, basically.
Yeah, it's still example 3.
We're just using the same.
We're using the same numbers, yep. Okay, so what am I filling in for y?
The parentheses thingies.
What's in the parentheses thingies?
2x minus.
Now, what's still on the other side?
4x minus 6.
And then you do the distributive.
What do you get on the left? Watch what happens.
What do
You
you
get. Oh, you
Oh my
get
god,
exact
it's
one.
the same.
It's
So
the
it's
same.
infinite.
Oh my god.
So
Then what would
Joe, I
it
feel like
be?
throwing a pen at you. but-
Well, now let's pretend like we want to move all our x's to one side. So how would you move 4x to the other
Wait, you would
side?
still solve even though they're identical?
yeah.
One
Is
more
that like
step.
some
Yeah, you get a
special
zero,
case?
you get a big fat 0.
No.
Oh.
How would we move all the x's to the right side?
Subtract.
Well,
Subtract.
Minus 4x.
Minus 4x. What's 4x minus
it
4x?
cancels out. And
4x.
that one does too, that's why I don't understand.
And then you add plus 6 to both sides.
You can stop here now, once we do this next step.
Because there's no more.
Oh.
There's no more variables.
What's left?
Negative 6 equals negative 6.
Now, ask yourself the same question we had last time.
Interesting.
Is negative 6 the same as negative 6?
One solution.
I don't know. Well, yeah.
Yes, it is, they're the same
Oh my
thing.
god.
So when you have two numbers that are the same and you don't have any letters left in the problem, what did we say that was?
I forgot.
That's
Infinite. It's the same problem we just solved up above.
What if he knows it?
It's the same one we just did up above. So infinite solution. Okay, when you have two numbers that are equal to each other, same numbers, infinite. two numbers that are equal to each other that are different, no solution. What does no solution look like if you graph it? What kind of lines?
Are they the ones that are like this?
Parallel. Ask yourself where they cross.
It's
No,
oh.
they don't. What do two lines look like that are infinite?
Like this one?
Right on top of each other.
They're right on top of each other. They're the same line.
Oh.
I know it's a little hard to see because my drawing is so good, but they're right on top of each other.
Okay.
Okay? All right, so that's what an infinite looks like when you do it with algebra. That's what a no solution looks like when you do it with algebra.
Now you have to do one solution. Right?
And we did a one solution right here.
Okay,
One solution. One solution. Algebra and a graph.
Okay,
the
these
first one
weren't
we did was
as
one
bad as
solution.
they
Yeah.
used to be.
The last one.
Oh, you guys had to throw a word problem in.
Yeah, I gotta throw that word problem. All right, so it says in a football game, the home team gets 7 points for touchdown, they get 3 points for a field goal, and they scored a total of 26 points. The team scored 6 times. I want to figure out how many touchdowns and how many field goals. All
I
right.
hate word problems.
So
Same.
what do we need first before we can even start to write this as equations?
You know they score a total of 26.
What are
26.
Collect information.
what are equations made up of?
The information.
X, Y.
An X is
It's
in
like
X's and Y's.
X's, W's, and
Okay, so we have to decide what our X's and Y's are going to be. What could X be? Think of something we don't know in this problem that they want you to find.
They want us
We
to
don't
find the touchdowns.
know.
Touchdowns. So we could let X equal number of touchdowns. It's not how much is a touchdown worth. We already know that.
7 points.
It's working for
It's how many touchdowns. Now, what could Y be? Something else we don't know that they're asking us to
Field
find.
goals.
Number of field goals. Not what a field goal is worth. We already know what it's worth, 3 points. It's how many did they get. Number of field goals. All right, so we have to come up with how many equations? 2. 2 equations. The 2 equations are going to come from there's one equation right there.
Shoot, I forgot how to spell field.
F-I-E-L-D.
And what I just put a box around, that's your second equation. The second one is going to be easier.
Okay, so
Let's do the second one first. The team scores 6 times. How many different ways can they score here? They can either score a...
They can score 2. They can score.
Don't, guys, don't overthink it. You don't have to worry about any like, numbers here.
How can they earn points? By getting a
Touchdown.
touchdown or a
field goal.
field goal. So,
So you have touchdowns and field goals.
Oh, I got it.
and how many total times did they score?
They scored 2 touchdowns.
Well, we don't know. We just know they scored 26
Again, it should be,
points.
you don't have to worry about putting any numbers with the variables.
How many
My brain.
how many scores were there in this game? How many?
plus Y equals 26. Wouldn't that be the first?
They scored 6 times.
Joe, can you say that again?
Wouldn't the first equation, or one of them be X plus Y equals 26?
Close. I like the X plus Y.
Or equals 6?
I don't know
Very
enough.
good.
I just didn't know if you.
What is X?
Number of touchdowns.
X is the
How many touchdowns they scored? What's Y?
Field goals.
Number of field goals. If you take all the touchdowns they scored and all the field goals they scored and add them up, the team scored 6 times. I'm not saying how many points they scored.
Why is that equation 2 though?
It could be equation 1.
Doesn't matter, either way.
I called this one 1. I called this one 2.
You
So-
just take it as set them up in the order they were written in the problem, that's all.
Yep. So the total number of touchdowns plus the total number of field goals is 6. Not the points. How many touchdowns, how many field goals? Now, the first one. It says all of the home team's points are 7 points for a touchdown. So if you get 7 points for every touchdown and you had 2 touchdowns, what would you do with the 7 and the 2?
Multiply.
You multiply,
Which is 14.
which would be 14. So we have
14x.
7, but how many touchdowns are we scoring? It's not 2. We don't know if it's 2. It's just x. If it's 7 times 2, if it's 7 times 3, 7 times
Plus 3y.
however many,
Equals
plus
6.
3y.
Equals 26.
Equals.
So this is the number of points for touchdowns. That's the number of points for field goals. What's the total number of points?
26.
26. Now we've got our system. Okay, we're not going to graph that. We're going to solve it. You have a choice. What are your 2 choices if you're going to use algebra?
Substitution or elimination.
Substitution or elimination? I'm fine with
Oh my gosh, I know what they
I think
are.
we should
Either one.
eliminate.
You want to eliminate? Okay. What do you want to eliminate, x or y?
I want to eliminate. Well, y is easier.
Okay, I would do y. Which equation are you going to have to multiply? Don't tell me what yet. Just tell me which one, top or bottom?
The bottom.
Bottom. So top we're going to keep. We're going to keep it the
Why would
same.
you pick the bottom one, guys?
Because y is by itself.
Exactly. It's already got a variable. It's by itself. It's easily changed.
Now, if we're going to eliminate y, the top one is 3y. The bottom one has to become
Negative.
negative
3.
3y. So what number would I put right
What are we
there?
multiplying by?
Negative 3.
Negative 3. Perfect. Top equation, what did I do to it?
Wait, do you
You
want
did
to
nothing
say
to
it?
the top.
Nothing. I didn't do anything to it. So I'm just gonna copy it over because I need some more room. 7x plus 3y equals 26. What about the bottom one? What's negative 3 times x?
Negative 3x.
What's negative 3 times y?
Negative 2.
Good. And what's negative 3 times 6?
Negative
18, negative 8.
Now, when we add these up, what disappears?
The Y's.
How can we say y still?
Positive 3, negative 3, 0. Positive 7, minus 3.
4.
26 minus 18.
8. What? Hold on.
Yeah, it's 8.
Yeah, it is.
Everyone agree with 8?
Yeah.
Yeah, that's right.
Oh, I was right.
Last step.
Divide
You
by
have to
4.
divide
would be-
both sides by 4.
Then
X
x
equals
equals 2.
With x equals 3.
So x is 2. What's x again?
Touchdown.
So they scored 2 touchdowns.
Oh, that means Y is 4.
And now how do we get y?
Because the bottom equation is simple.
But you can also substitute it.
Yep, we're going to substitute 2 in for x.
So you
2 plus y equals 6.
So it's subtract 2 to both sides, and then you get 4.
Or you could just know it's
So
4.
that works too, yeah.
We were playing fast.
So let's check it. What's each touchdown worth? Touchdown is worth how much?
How
many?
One's the touchdown.
7.
Touchdown is
How many
worth
touchdowns
7
did they get?
points.
2.
So they got 14 points in touchdowns.
How do you already know the answer before?
What's y? Y is the number of
Field goals.
field goals. What's a field goal worth?
3.
3. 3 times 4 is 12. What's 14 and 12?
26. Alright, so we got
26.
See, this is complicated on the test.
On the test, I would literally cry and rip my paper up if I saw this problem.
2 touchdowns, 4.
You guys, again, if we gave you, if we didn't give you a word problem like this on the test, we'd have you put this example on your notes, on your reference.
Yep.
What's a good song?
Oh.
Go.
Okay, couple quick reminders. Homework tonight. Guys,
You guys get a couple practice problems after this, so you have some time.
homework tonight. 5.4. Yep, 4th quarter, first week.
Guys, listen up, please. All right?
Test on Friday.
Remember, guys, this week, we do have a review day built in this week on Thursday. All right?
May.
April.
Oh, like April.
Oops, I don't know why I did that. This should say April, if it's from last year, it should say April 30th.
Maple.
Maple.
Syrup.
I like maple. That's a really cool word.
So we have 2 weeks off. Now, guys, next thing's very important. Okay?
I'm gone.
next academic week. All right, so it's a ways off because when you guys come back, we have vacation. When you come back, it's shop, and then the beginning of like the last week of April, last day of April into May, right? That'll be our next academic week. That week, guys, I will not be here.
Why not?
All right, my wife is due to have a baby anytime.
Are you serious? You didn't tell me!
For some reason, guys, we just didn't have a chance. I don't know why we didn't. We just didn't have a. I don't know why.
Are you serious?
I'm serious.
Is it a girl?
Boy.
I knew it.
That's good. I don't like girls.
Yeah. So, guys, that next academic week. All right. That next academic. So on Friday, what we'll do, guys, we'll do as a bonus. Well, let's put it this way. There'll be a bonus
Guess the
question
baby's name.
on the test on Friday.
Is it guess
All
the
right.
baby's name?
We'll
Yes,
see.
it's
All right.
named
So,
after Tom Brady.
guys, I'll be out. Like I said, that next academic week, I'll be out. Don't worry. All right. A few weeks ago when I was out, Mrs. Gogan came up here. She'll be so.
Well,
She kept looking at people. She gave me a really hard time. I felt really